1995, astronomers discovered the very first extrasolar planet, a planet orbiting another sun-like star. Now, in 1992, 3 years earlier, they had actually discovered a planet beyond the solar system, but it wasn't orbiting an active star. It was orbiting the dead remains of a star called a pulsar, which we'll talk about in a later lesson. But here in 1995, the first planet orbiting another sun-like star was found. That star was in the constellation of Pegasus, about 50 light years from the Earth. And if you remember when we talked about naming stars, remember that we use a Greek letter from alpha to omega with the genitive name of the star, of the constellation, that the star is in. So in this case, it's in Pegasus. The genitive would be Pegasi. When we run out of the 22 Greek letters, then we go to numbers as the stars get dimmer and dimmer. So this star was 51 Pegasi. 51 tells you it's a pretty dim star. It's very hard to study it. But the object orbiting it, the planet orbiting it, came to be called 51 Pegasi b. Remember that we talked about naming multiple star systems, and we said you can stick a letter after the name, so Alpha Centauri A, Alpha Centauri B, Alpha Centauri C. That's a capital letter, so that indicates capital letter indicates that you have a multiple star system. A small letter indicates that you're talking about a planet orbiting that star. In any case, 51 Pegasi b was discovered using the radial velocity method that we talked about in the last lesson, looking at those small Doppler shifts, oscillating Doppler shifts in the spectrum of the light. Very, very difficult to do. You'll see a little video on how they did it shortly. But in any case, for our purposes here in terms of understanding how we test scientific theories, remember that the nebular theory predicted that all gas giants should always be found far from their parent star. Here we had discovered a gas giant about half the size of Jupiter. The question was, does it orbit far from its star the way nebular theory and kinetic molecular theory said it must?
A Jupiter-sized planet had been discovered. This massive planet was making a complete orbit of its star in only 4 days. How could that be?
Suddenly there's this 51 Peg, which is a Jupiter-sized planet, but in a 4-day orbit. And people knew that was impossible. If Jupiter-like planets orbit at like Jupiter and Saturn orbital distances.
People knew that was impossible. How did they know that? Well, because remember, kinetic molecular theory tells us that only far from a planet's star, beyond the frost line, are the gas particles moving slowly enough that they can actually accumulate to create gas giants like Jupiter and Saturn. But here, with 51 Peg b, astronomers had discovered a gas giant similar to Jupiter, only it was orbiting closer to its parent star than Mercury orbits to our sun. Mercury has an 88-day orbit around its sun. 51 Peg b has a 4-day orbit. Mercury is about 50 million kilometers from the sun. 51 Peg b is about 8 million kilometers from its sun. How could that possibly be? Well, based on everything we understood up to that point, it couldn't be. So here was a very, very shocking contradiction of nebular theory. In the next video, we'll look at how scientists deal with the appearance of evidence that contradicts their theories.